Okay, good morning class. So at this point we're looking at Euclidean Geometry, and we are doing examples for exercise 5. And exercise 5 is on page 267. Okay, so in example 10 we are told, let's put here page example 10, and this is on page 260. Can't be 265. 265. Okay. So we're looking at example 10 on page 265. We are told that, let's put this here, make it a bit smaller. Circles A, B, and C. A circle A, B, and C. So that's A, B, and C, which is the circle here. And A, B, D. A, B, D, which is the other circle, intersect at A and B respectively. Respectively means to say in that order. AC is a tangent, so AC is a tangent to circle ABD, which means to say that A1 is equal to angle D. Why is that the case? Tan chord theorem. Okay. Then we are told that you must prove that BC over AC, so BC over AC is equal to AB, AB over AD. So from there we know exactly which two triangles to work with. Which two triangles that we need to work with? Triangle. So we say in triangle ACB and triangle ABD. You see here the order wasn't given. Where are we going to get that length from? We are going to get it from proving similarity. So what I'm going to do is I'm going to prove that triangle ACB is similar to triangle ABD, and then I can go with the length question, or the length section of the question. You guys understand what I'm doing? Who's confused? Got in yellow, you understand? Glad you're awake. But you guys understand? Right. So, what can we say about the two triangles? Firstly, I already marked it. A1 is equal to angle D. So, angle A1 is equal to angle D. Why? Tan chord theorem. Okay. Another one. Oh, they told us, I didn't even read this one. AD is a tangent to the other circle, which means to say A2, so AD, which is this line here, is a tangent to the circle going through here. So A2 is equal to angle C. Why? A2 is equal to angle C, tan chord theorem. Okay. Tan chord. Right. Now we need one more. The third one is B1 is equal to angle B2. Why? It's the third angle of triangle. The third angle in the triangle. People, is that enough to conclude similarity? Yes. We proved 3 angles are equal. So, yes? Sum of triangles? Yes? So I can say, therefore, triangle ACB is equal to, sorry, is similar to triangle ABD. Why? Because of angle, angle, angle. Okay. Yes. The order. Just before you ask a question, your order. You want to ask about the order. Okay, just hold that up now with you. I just realized now that this order was not given to me. So I needed to check that the order is in the right order. Why? Because when I draw the ratio question, the ratio part of it, the order must be in the right order, or the triangle must be labeled properly. You guys understand? So if you go with angle A from this triangle, ACB, which is this one here. So I started at A. So where must I start? Here in triangle ADB. A is equal to which angle? D. So I must start with triangle D. C is equal to which angle? C. Is it? You mark to the X. You mark A is. And then B. So that must be the order. Okay. So the corresponding angles has to be equal, which will result in its corresponding sides being proportional. Then I can draw it from here. Yes, Michael, what's your question? Yeah. Then you will show that the question is, would they ask you to prove similarity given sides only? Yes. If all the sides are in proportion, then the angles will be equal. So they must give you 3 sides. Yeah. Okay. But in the converse of the proportionality, they'll give you 2 sides. But for similarities in converse, they'll give you 3 sides. Now that would be sides in proportion. That would be your reasoning. Okay. Now those type of questions will still come. Good question, you ahead of us already. Alright. People, what can I conclude from here now? I can then say, therefore, AC over DA is equal to CB over AB equals AB over DB. So I say AC over DA is equal to CB over AB equals AB over DB. Why? Because triangle ACB is similar to triangle DAB. Or you can write sides in proportion. Okay, both will give you the mark. Now coming back to what they want. Okay? Always come back to what they want. What do they want? They want BC. Do we have BC here? Where? BC? Yes? Do they have AC? Yes? They have AB? Yes? And they have AD. But is that the order in which it is here? No. The BC is on top with AC at the bottom. So those two must interchange. Can you see that, people? So what do? I then say, therefore, CB over AC is equal to AB over DA or AD. People are something like this is worth 6 marks. Okay. You see how easy you can make 6 marks? We have back 6 marks. Okay. What? Seems easy, no? That's how it is, man. It will always seem easy if somebody else do it for you. Okay. So when you must do it yourself, which you guys don't do. It shows in the test. Okay. You tell yourself, that stuff is easy. I don't have to study it. Until you get the test. Alright. People, any other questions regarding this? You are moving too fast. Huh? Okay. Yes? Okay, there's a question. Shh. Second last line, yes? This here? Of course. Of course you're going to lose it. What kind of girl are you then? Listen, you must remember that I won't give you unnecessary stuff. If it's unnecessary, I will tell you. Like when you go with angles in the same segment, I always tell you, it's not necessary to say it. No? When you name the arc. But I do it. Okay? If it's not necessary, I will tell you it's not necessary. But this is necessary, otherwise you will be losing money. Because if you get to here, that's already 5 marks. No? And you leave that out and you go from there straight into this, then you lose that last mark.
So it's 6 marks.
Well, yeah. The reason why they don't give you a mark here is because that's the question. We must not give you. So we're giving you the answer already. So we can't give you a mark at that point. Okay, anything else? Okay, so what I'm going to do is I'm going to take this off. Okay? But I'm going to keep this here. Here we go with that. Okay, so in A we proved that, and we managed to prove that that is A. Let's look at what B says. In question B, they're talking about AB squared. Okay. Now what you notice, that is also a length question. Can you see that, people? So again I write, it's coming from A that, okay, I had to actually keep the ratios as well. This you don't have to repeat in the next question. Why? Because we already have it in the first, from the first one. Eh? We know that AC over DA is equal to CB over AD equals AB over DB. And we had our reason there as well. Not so. Now looking here, what do they want? What is AB squared? How do you get the AB squared? You use AB twice. So these are AB and there should have been an AB. So it's AC over CB over AB. This is the AB. It looks like an O, and it's a B. Okay, there's your AB. Not so. There's it. And then you got BC and BD. So what do you notice here? That is cross multiplied. So therefore, AB squared is equal to CB times BD. Okay, you guys understand? It's going to be safer actually for you to put that as part of your solution. Because in other words, you're just writing the question down. Can you see that? Yeah, so rather it's going to be safer for you to do that. Okay. You can either write the sides are in proportion, or you write the two triangles are similar. Okay. But anything else? Any other questions here? No? You guys understand, eh? Right, let's go to example 11. This is for exercise 5. Correct? And exercise 5 is on page? Now, why didn't you tell me I must change that? Sorry? I wouldn't ask because if I knew, then I would have changed it. Okay, this is number 11. Example 11. Example 11 is on page 266. Correct? Right. So let's do this. In example 11, we are told that P, Q and PS, PQ and PS are tangents to the circle PRST. P, QR, QRST. Okay. So let's pause the video quickly and align the board. Let's hope that did the job. Okay, so if those are tangents to the circle, what do we know? That Q1, yes, is equal to S2, yes, S1 Q2. What else do we know? Sorry? PQ, yes. PQ is equal to PS, yes. Okay, so those base angles are also equal. Okay, you all agree with that? Right. Then we are told that we are required, then we are told that those chords are joined. Then we are told that PQ is parallel to ST. If PQ is parallel to ST, what can be concluded from there? S3 is? S3 is equal to PQS. This is the whole angle. Why? Alternate angles are equal. Right. What else? P1 yes? P1 is equal to T yes? Why? Alternate angles yes. Nice. So by just saying those things, we know many things. Okay. We also know that angle T is equal to angle Q2. Why? Angles in the same segment. Can you see that coming from chord or arc? RS. Okay. The question says we are required to prove that QR squared is equal to RS times RP. So somewhere I need to prove similarity of two triangles. Can you see that? I need to prove similarity of two triangles. So looking at QR, this is QR. So this line I must use. How many times I use this line? I must use it twice. Okay. Why? Because it's twice represented in the what we needed to prove. Okay. So let's make triangles dealing with QR. Let's see. QR, P is one triangle here, and QR, yes. Can you see that, people? Let's see on the other side, the equal sign, they use RS, which we will be picking up there if we use that triangle, and RP, we will be picking up here once we use Q in triangle QRP. Can you see that? Does it make sense, people? Right. So let's set those two triangles quickly. So we say in triangle. We start by saying in triangle. So here the order doesn't matter now, but in the conclusion the order matters. So it's in triangle, PRQ, and triangle RQS. Okay. What can I say about those two triangles? Okay, let's just highlight this quickly. The board is jumping around. Yes. Okay. So let's go. What can we say? Q1, yes. Q1 is equal to S2. Why? Tan chord. Tan chord theorem, no? Right, what else can we say? S1. No, not S1. For these two triangles. Yes?
You can say that P1 is equal to T.
Yes, there we go. Angle, just a second, you're too fast. Angle P1 is equal to T. Why? So alternate angles with PQ being parallel to ST. Okay? Then angle T is equal to S1. I mentioned that, no? So that will also get an X. That also get an X. As that has an X. You know? Q2. Why are you saying S1? Yes, it is actually equal to S1, and then you're going from S1 to Q2. Is that what you say? But you can go straight from T to S to Q2 also. But if you had got that route, you would have got an extra mark. You just get the full mark as well. Okay. So that's going to go to Q2. Why? Because that's angle in same segment and it's coming from arc RS. You don't have to say the arc is in. So in conclusion, I can then say that P1 is then equal to Q2. You can say proven, or we can just leave it like that. That's the second point. No? The third one, the third angle, is going to be in this triangle here. I'm shorting angle R1, not so. So R1 has to be equal to which angle didn't I work with in triangle RQS? QRS or R2 and 3, the combination thereof. So it's going to be QRS. Why? Because that's the third angle in triangle. Is that enough to conclude similarity? Yes, sir. It's enough to conclude similarity. So, and the order, don't forget the order. It's important. So I can say, therefore, triangle PRQ is similar to triangle. So here we go. P, which angle does P correspond with? Q. Although it's T, yes, but in this triangle here. So P is corresponding with Q. R is corresponding with R. And Q is corresponding with this. Does it make sense, people? And what's my case of congruent similarity? Angle, angle. So what can we derive from this now? From this information? We can derive our sides that are in proportion. Not so. So what can I say here? PR over QR is equal to RQ over RS. This is why order is important. Equals PQ over QS. And what do we write here? Sides in proportion. Okay. So now we go back and we see what they want. They want QR squared. Just take this. Just write it here. I'm looking up all the time. So it's going to be QR squared is equal to RS times RP. Okay. So they want us to use two QRs. Are they two QRs? Yes. There's your RS and there's your RP. So what do we need to do? Cross multiply. So what do we get here? We can say therefore QR squared is equal to RS times or PR or RP is the same thing. Okay, any questions here? Yes? You guys understand? Okay, and there's only 2 examples before exercise 5. Okay? You guys can do all the odd number, every alternate Sunday, starting with, is it number A, B, C, no? Is it 1, 2, 3? You do the odd numbers there for me out of exercise 5 forward. Alright? At this point, I'm going to stop the video. It's already long.